Hello, welcome to Econometrics Melody. This tutorial is about the two-way plot types in Stata. From this tutorial onwards, we'll be focusing on the two-way plot types in Stata. This tutorial is about scatteri, scatter, and connected plot types in Stata. These are also the commonly used two-way scatter types in Stata. This is our data set for, and the first plot type is two-way scatteri. Scatteri implements, so scatteri means scatter with immediate arguments. So we specify the scatteri and we provide the y value and x value along with its position. So this position is a clock position, and this is the label, and EMS stands for marker symbol. So let us use this. So the label is a 12 o'clock position, and we are going to the next one is, so any two-way scatter, any two-way plot types in Stata can be combined with this binding notation. There are two ways to write it. So we are trying to bind two scatter plots, two scatteri plots. So 1833 y3x3 position 12, we want to write welcome, and another 866 y6x6 and the position is again 12, and we want to write again welcome. Marker style is circle for the first one, and for the second one it's a triangle. So let us see how this will work. So the circle and triangle, the label is a 12 o'clock position, and let us repeat the same graph by using the separator or separator symbol. So the first scatteri inside this place, and the second scatteri inside this place, and we have separated it using this separator. Here we have separated using this small bracket in both the case, and these are the common options. After the end of the separator, whatever the options we apply, that is the common operation for the entire graph. And let us see, are similar. Now again, let us explore other features of a scatter plot. So scatteri immediate argument 3 and 3 x3 and x3 y3, we want to write welcome. Marker symbol is the circle. Marker colors should be filled with green. Marker size is 48. Marker line color, outline color is yellow, and this will be evident once we see this graph for this. So we have a marker line color yellow, this is the outline color. Marker color is green, and the label it's white. We have increased the label side, and we have two lines, it's y3 and x3. Y line is 3, x line is 3. Marker label size hues, and a marker label, this is the label marker label color is white, and it's at 30 degrees, its angle is at 30 degree. Now let us manipulate this label position angle actually. So from 0 to 360 degrees. So I have written a loop for it, and let us see it for ourselves. So we have written a loop, and this I will be called at a marker label angle. So it will increase at the 40 degree at the difference of 40, and we will see the positions of the label 0, 40, 60, 90, and so on. And if we look at this marker is centered at 3, 3, which is immediate by this scatteri 3, 3, one plot. This is one dot, one point, and the label is angled at 0, and so on. Now let us drop all the graphs and let us manipulate its clock position styles. So its position here. So this is the clock position. So from 0 to 12, and it will increase it. The difference is 1. And let us see from 0 to 12 what will be the position of the label. First at 0, then after it 1 o'clock, 2, 3, and so on, all the way to 12 o'clock position of the hour hand. So this is interesting. Now let us combine more than two scatteri. So it y9 x3 and at position 12 we have hello. At y5 x6 and at 6 o'clock position we have welcome. So we have 3 points using first scatter eye, 3 scatter points, and using second scatter eye we have the same points, but their marker size and marker color and different styles, they are different. And let us see what kind of graph do we get. So 3 points. So this is the graph. Now let us drop them all. The scatter eye, we provide the immediate argument, and so we'll have to specify two-way scatter eye. Let's say at 10, 10, and at 2 o'clock position, we want to write some label called scatter eye graph. If we run it or if we execute it, we'll get this graph. And we can manipulate this marker size, color, and so on. So this much for a scatter eye. Now let us move to the scatter plot. A scatter plot is a two-way scatter plot. We can plot the x and y, several plots of x and y, and we have here again we have used this binding notation, one scatter and two scatter. The first scatter is marker symbol is noted by triangle, hollow triangle, and the second scatter is noted by plus sign, and which will be UVTM once we plot it. So the hollow triangle, it is a scatter between income and expenditure, and the plus sign, it is the scatter between import and export, and we have provided this other styles. Similarly, we can use the separator to draw the same graph, and we have specified this separator, which is clear at the end of this scatter. Same graph results by using separator as well. And if we notice, we have used two scatter, but our x is export and our y variable is income and import. So in order to draw this, rather than specifying two different scatter, we could have specified two y variables followed by the x variables. When we provide the variable list, the last variable is treated as x variable, and the variables preceding the last variable is treated as y variables. So this is the same graph, and if we, for our comparison, we can combine these three graphs and we can see it for ourselves. They are one and the same. Now let us explore some other features. Drop all of the graphs and scatter eye. Let us again explain it. So this is the last variable, x variable, and if any variables preceding the x variable are y variables, and let us see what happens. This is a simple scatter graph. So marker symbol is there are two y variables. So the first y variable is going to be represented by this x sign symbol, and another by plus sign, and which will be clear once we plot it. So this is the graph, plus and x sign. Similarly, if we use this connect, we can connect this scatter points. The first one will be connected by L stands for line. The second one will also be connected by line. Let us again show the plot, and we see now they are connected. So it is always good to specify the sort option in order to avoid this kind of confusion. So we sort these variables, y variables is for the x variables, and we get a fine graph. Now they are the scatter plots of two different y variables along this x variable. They are connected and sorted as well. And if we combine this, we will see a clear picture. So we begin with a normal scatter plot, and after we connected it with lines, after connection we realize that it should be sorted, and we sorted, and this is the final result. Now let us explore the options and styles of markers. M stands for marker, marker symbol, marker color. The first option is marker options, and we can manipulate the marker look and feel of the marker, symbol, color, size, its fill color, line color, outer line width, and the style. Marker label, the labels. So these are the style options and styles for marker label. Its position, marker label position, And connect options, we can use these options in order to connect the scattered points or plots. And these are the other options. Option number F, G, they are the common options that we have explored in our earlier videos as well. Please go through it, and in case of confusion about the kind of symbol styles or other styles, we can always type graph query followed by the style that we have to explore. For example, if we type graph query symbol style, we'll get the list of the symbol styles. If we close this, and we'll get the list of the symbol styles. For this, these are the symbol styles, and if we type graph query symbol, these are the list of the symbols. Graph query color styles, these are the list of the color styles, and so on. Please refer to video number 2 or 3, 1, 2, 3 for this general styles. Now let us explore the above styles, marker options style, and let us manipulate the look and feel of the marker. The marker is filled with yellow, line with black, its size, we have increased the size, color green, marker size, marker fill color yellow, light color, and width. These are very simple. And let us marker label options. Let us change or manipulate the labels. So we have a scatter plot. This is the scatter plot, and we have a label, the marker by district. So these are the districts, and any point or plots, scatter plot, that without these districts are the missing values actually, or the district for these values are missing. So marker label size is large. This is the large size. We have filled it with blue color, and the marker label gap is 2. Now let's move forward. So let us export the connect options, whether we want to connect these markers or not. So there are certain connect options. If we write a yellow, we can connect it with line. This is the fine line, and we have see missing. Yes, we have specified the missing option. So missing observations would also be connected, and if we specify no, the missing observations won't be connected. And we have given this style. You see here's a break. Once we have specified missing no, so missing observations are not connected. So let us connect them, and connection is, we connect it with a line, and we can manipulate this line pattern, line width, and line color, and so on. Now let us see what are the possible connected options. I have written a loop for it, and we can see it for ourselves. None, if we specify none, it will not connect. Direct, ascending, staircase, and step. Stair, let us see it for ourselves. None, direct, ascending, stair, step, stair, and so on. And once we combine it, this will be clear. So these are the different connect styles. Now let us see what happens if we specify see missing yes or no. So first of all, let us drop all the graph, and then let us see what happens if we specify yes or no in case of see missing. See missing yes, see missing no. So this is the difference. There are the breakpoints. We have seen it already. Let us drop them all. And jitter options. So in case of overlapping of the scatters, we can always specify jitter options. So this graph is overlap, jitter 10, jitter 20. So the overlapped graphs are scattered. They get some space to breathe. They will have some breathing space. So jitter 0, jitter 10. So overlapping points, they get some space, and this is the wider space. So let us drop them all. And the axis twice options, let us also explore the axis twice option. So here axis 1, 2. So we have two alternate axes, two x-axis and two y-axis, and let us see what happens if we specify this. And did we not combine it? And let us combine it. So this is x-axis, and this is the above one is the alternate x-axis, y-axis, alternate y-axis, and we have activated the alternate. Here it's normal x and y, and here we have activated the alternate y-axis as well. So the label appears in both the y-axis. Here we have activated the alternate x-axis, and here we have activated both the alternate x and y axis. Now let us see a simple example, and we can provide a weight as well. So we are going to draw a scatter plot of income and export, and the weight of the scatter or the marker size, it should be carried from this import, and marker symbol is hollow circle. So we can guess. Then here we have the higher import. This position it has the lower import because our weight is import. This is a very useful option that we can have. And we can even specify the label, mlabel district. So marker symbol, we have ignored the marker symbol, so we don't see any marker symbol. The district, the marker is labeled by the district. Label position is 0. And let us explore this. We have two scatter of income and export, one with weight and one without weight. And let us see what happened. We have specified the label and the size. So the bigger or smaller marker is due to the first scatter option with import, and the second one, from the second scatter we get the labels. So this is also one of the payoff. Now let us replace something and see the other options, and we will say this is the missing one. So we get a new label called missing. So this is what we have introduced here. Now let us see example 2 for the P styles, and let us, here we have 4 markers, 4 scatter. We have binded 4 scatter, 1 2 3 4, and we'll get a 4 legend for this. And now each scatter are differentiated by different color, and if we want them to have same color, so we can make use of this P style. So I have specified by default the first graph will have P style, first P1 style. So if we want to have similarities in all the rest 3 scatter graphs, then we'll have to specify P1, then we'll get the same graph, the same colors. And we can manually inject different P styles. We have P7, P10, and P14. We can define the P styles from 1 to 15, and we'll export it later. Okay, so these are our manual inputs. So we have defined the P style, P7 for second, P3 for the first, and so on. And we can always off this legend even if we don't like this legend to appear. So we can always off this legend, and this is a break, and we can write legend off. And again, once if we run this, we will not see the legend. Now if you want to explore what are the possible P styles, and if you want to see it, let us run a loop for this. 15 P styles, P1, P2, all the way to P15. They are differentiated by the colors. These are the extended colors. So all the way to P15, from P1 to P15. We can choose based on our choice and our preference the color. We can specify the respective P labels, P style. Let us drop all the graphs and let us move forward. Example 3, using by, it's again a simple case. We want to draw a scatter plot by district. So there are 8 to 10 districts, and we want to draw a scatter plot of ink and import for these districts A, B, C, and total. And have we restricted if n is less than 700? So the sample size should be less than 700. So the up to 700, it covers only 3 districts. Doesn't matter. And we have specified this total, and this is the total scatter plot of all the 700 points, and these are the respective distinctions of the districts. We should have specified total. This is the sub option of by, and we have sorted it. Now let us see another example. So we can also, for this scatter, the scatter is one of the scatter. It's one of the plot type, two-way plot type. Similarly, lfit, linear fit, is another plot type, and lfit ci stands for confidence interval. This is another two-way plot type, and we can bind them together to get the results, and we can according to rules. So if we specify the ci, it covers the area, so the precedence of occurrence also affects the result. So if it's the scatter graph first, followed by lfit, followed by lfit ci. So this is the area graph. So area graph covers all the preceding graphs. So in order to display the required result, we'll have to specify the area graph first, followed by the other graph. So this is the result. Now let us quickly move to another graph for two-way plot type. It's connected plot types. Connected graph two-way connected is a two-way scatter plot type with default connections. So two-way connected, this is a simple graph. If we draw the scatter plot of the same graph, we'll get the same result, but if we connect it with line, we'll get the same result. And if we combine both of them, so what is the difference? We have not specified connect option at the first, because by default it's connected. And if we draw a scatter plot of the same variables, and if we specify connect by L is by line, then we get the same result. And if we combine it, we won't see any difference. So this is the scatter plot. So this is the plot, a two-way connected graph, and this is the result after applying scatter, and m symbol is circle and connected line. So this is a similar graph, and making use of the scatter eye, we can go, or we can be as artistic as possible. So before we conclude our results for this tutorial, so we have used the scatter eye in order to draw this. Let us drop all the graphs that we have. So thank you very much for your time. Thank you very much. Econometrics Melody.